Yeah, hello and welcome to the 8th and last lecture in OOP1, which is today about templates and some further selected topics in object-oriented programming. Yeah, as I said, it's the 8th and last lecture today. Next week you just have the KU again, but the lecture part is finished with today.
Yeah, and we have one last topic, which is templates, and then a few additional small ones. Let's call it like this.
Yes. But if we start with templates and those further topics, we make a little recap from last week's lecture, which was about operator overloading, and we have prepared a slider for you. So please have a look at the code here and tell us what the output is.
I think it's actually very, very similar to what you've seen in the practicals before.
Yeah.
So let's see if you paid attention there.
So basically we have a character class, we have two operators that are overloaded here, and we have a main function. I think we can wait a few more seconds.
Yeah.
Hopefully to reach at least 10 answers.
So maybe you also have to join. You can reach the 10. But the answers, so I already can see the answers. The answers are,
oh, yeah.
Yeah, quite interesting.
Challenging.
All right. Yeah, we reached the 10.
Reach 10, yeah. So let's have a look on your answers. And the winner is Night King, which is unfortunately not the correct answer. The correct answer is, now it's the winner for sure. Knight is the correct answer. It's not Night King, it's not King Knight, it's not King, and also no runtime or compiler error. But yeah, let's have a look why it is Knight. Yeah, some of you have assumed that since we add here first and sec, we get Knight as a result, and for the operator, the output operator overloaded here, we assume that with the get name that we call, we get king as return value, but that's not correct. So what happens here? We have, as I said, two characters, first sec, which are called NI and GHT. But here we have first plus sec, so we have character plus character. So here we have the operator plus, which is called. So the plus operator is called with the right-hand side character as argument here, and the result here is the name of the left-hand side plus the name of the right-hand side is returned as new string. So the result of this plus operation here is, the concatenation of those both strings, which is night, but then some kind of tricky here, the output the overloaded output operator is never called, since we do not call it with a character object on the right-hand side. So it's just here a string that we've got back from our plus operator. So it's just here the output of a string, okay, and not of a character. Would have been different if we just say cout first, but here with first plus sec we get a string, so it's just the output of a string.
Or if the the plus operator would return a character, then it would also work. But in this case, it returns a string.
Correct.
Just we print out the string. And this example is very good and shows you that it's not that easy to identify which operators are called and which operators, even if they are overloaded by you, it's not so easy to see which one are called now. So perfect example to show it's hard to identify.
Yeah, correct. Okay.
Any questions to this? Yeah.
Yes.
Is it good coding style to use this pointer all the time if you call a method?
So the question is it good style to use this?
So you mean here in this case?
Or just in general use it?
Yeah, so I would say it makes it more implicit, specific and explicit, especially when you're using in operators where you have a right side and a left side, and the left side is the this. It's just better visible to distinguish which one you are meaning. So I would prefer writing this, but it would also work without. So, yeah.
Further questions to this example? Okay, then let's move on to the first topic for today, which is template functions. And we want to start with a short example where we want to calculate the maximum. First, we want to calculate the maximum for two integers. And it's not a big deal to do this, so we just have a function here taking two integers, and here with this comparison operator we look which one is greater than the other and return the maximum in this case with this ternary operator, returning an integer for sure, because the maximum of two integers is an integer. But what if we want to extend our program that it also is possible to compute the maximum for two floats? What would be the solution for that in this case? Someone has an idea? What is the first intention for you to do if we want to extend it, that it also works for two floats?
Yeah.
I'm not sure because I'm not that much experience with C++, but what you can do, for example, when this is Java, you can overload your methods that you have the same name but different arguments, and then depending on what argument you ask, the according method is going to be called.
Thank you. That's correct. That's the first solution, function overloading. So we want to do this for floats. We can write another max function with different signatures or with different number of parameters or different types of parameters, in this case two floats, but the calculation for two floats is for sure the same, and the return value now is different. It's a float. But now we want to do this for some further data types as well, but we always have the same implementation inside those functions. So this is not that nice if we extend it for each type we want to have. And this is somehow the motivation for today's first topic, using template functions. And now we have a look how this works. So we design a template in our example, the maximum calculation. And this template then should work for an arbitrary type of data. So in this case, yeah, we just replace all our integer or float declarations with an arbitrary data type, in this case with the T for template. And the only thing we have to do is to say to the compiler, this is a template, by specifying it with template T. And then we can write T everywhere we had integer or float before, and the implementation inside the function is the same. So this basically is the template for the maximum functions we've seen before with integer and float.
So T is basically just a placeholder for any data type.
Yes, correct. And yeah, let's see how this works with a small example. So we have again here this template, now with some const, and only to show you that it works with const as well, and also with references. And we have a short main function here where we call this max template once with 2 integers and once with 2 floats.
What does this F mean here at the end?
F is just a specifier that it is a float and not a double. Yeah, and the output would for sure be 42, 42 in both cases. Since we do not have some end lines here or new lines, it is 42, 42. And what the compiler does is taking this template and replacing all our T's with the respective data types that we need in our program. But not for all possible data types, but just the ones that we need. So in our case, it's just integers and floats. And so the compiler creates the integer and float maximum calculation functions for us out of the template. This is what happens when we compile our code.
So we can only, or we are only, we need to write it only once, and the compiler duplicates the code for us whenever we need it.
Yeah, and this makes it easy if we want to use this max function not only for integers and floats, but for any other data type as well, where we want to compute a maximum. Now, yeah, just again about template functions. So as I said, the compiler just creates the specific functions as they are required. So as we need them in our program, and for sure those templates need to be seen by the compiler, so they are usually defined in header files. Now let's have a look at one further example where we have a specific or a custom data type in this case, which is a bunny. So we have a class bunny, we have with an age, with a constructor and a getter for the age. And then here we have our template again, where we want to compute the maximum, from A and B, again with the same implementation. Now, if we have a look at this main function, then we see we have here our standard out, where we call the max function and we pass bunny with age 1 and bunny with age 42, so 2 different bunnies, which we can do because, T can be any arbitrary data type. It's not integers and not floats in this case, but it's 2 bunnies, which works as well. And after that, we hopefully get the maximum, so the maximum bunny. And for this bunny, we call getAge. So what do you think will happen, or what will be the output?
Yeah.
I think it will not work, or probably give us some cryptic output of the hash codes, because we have not yet overridden the operator for the greater sign, so it does not know that it needs to compare the age.
Yeah, correct.
Yeah, exactly. So it would work for integers, maybe for floats or whatever, but for our custom data type, it will not work because, as you said, this operator here is missing.
Yes, correct. But this is not something that the template doesn't work, but the problem here is that the comparison between two bunnies is not specified because, yeah, what is the maximum of two bunnies? Is it the size? Is it the weight? Is it the age? So in our case, we just have the age, but in general, so the compiler doesn't know what makes a bunny greater than the other. So yeah, as you suggested, the greater operator could be overloaded. This would be one solution, then it would work. And the other solution is to make a further template for this bunny, which then gives us a specialization of this template, and this works as you can see here. So we somehow have to specify that this max template is for bunnies, and then we can say, yeah, we take those two bunnies and we do not use this greater operator for both objects, but we use the greater operator or this greater comparison for the ages of the two objects by calling get age first, then we have two integers, and then we return the bunny which has the higher age. This would also be possible how to make a template specification for custom data types. Yeah, that's a very good question. So what is the benefit of doing it like this and not just overloading the operator? So in this case, we can call the max function for two bunnies, but we cannot compare two bunnies anywhere other in any other place in our program because this is not specified. So if we do not want to offer comparisons, but just the max function, we can do it like this.
Why not just overload the max function with the bunny? Because couldn't you just write the max function
Yeah.
with the bunny as arguments, and since the arguments differ in the data type, it would overload the function itself and not the operator?
Also good question. So why not just write a max function with bunnies instead of a template would for sure work as well. So
yeah, would work. But then it would also only work for the bunnies.
So can you not make a template for all data types and then a separate overload without specifying it as a template?
Yeah, but at some point you need to have a comparison here. And yeah, of course, if all of them has this get age, then it would work of course, yeah.
If you just remove the template and the curly brackets and just write that the parameters are of the type bunny, then it would overload the function, right?
yeah, so you mean one template function and one max function for bunnies?
Yeah.
Does this work? So if I have a template and then one specific max function?
Yeah. So because the compiler translate these templates functions to functions whatever it needs, and there's one additional function in there.
The compiler just does the same thing. He also makes overloads then for
Yeah.
every use. So what's the benefit of making a template function if there's just one type that can use the template function, because then the compiler will always just put in your bunny function because you only have the bunny that's of type bunny.
So yeah, the question is, what is the big benefit? And it makes totally sense what you are saying. And this example is a bit arbitrary, I have to admit. So I also would prefer to overload the greater operator because it's made my opinion makes much more sense, because they can then use just this function here. We just wanted to show you that there is an alternative way, although I wouldn't do it like this, to be honest.
I know what you mean with the overloading of the operator, but I mean, like just overloading the function max itself, like just putting another function without the template keyword and without the bunny in the pointy brackets, and that would just be an overloaded function.
Yeah, as we said before, that would work. Yeah, but we can discuss this later if you want. Yeah, so maybe we should continue now. Yeah.
Shortly. But then what if we, let's say that bunny is a subclass of an abstract class animals. If we make a separate template for animals, for Max, does that mean that every subclass will behave in this way? For example, if we pass in our Max, in our original Max, we pass a float, a number, or whatever, it will just work as it says there. But if we pass something that is a subclass of animal, like bunny, dog, or something else, will it correctly execute or call this other function because we specified the abstract type animal?
So if there exists a parent class of bunny, and we have, if it's abstract, so we just have then bunny objects, right? So we always come to this function here. But if we have not an abstract class, but a normal class, parent class with animal objects, and we call a max function with those objects, they are not bunnies, so we would come to this template then.
But if we specify in the second template where we put bunnies, that it is an
Animal. Ah, okay. I think this one will then be called, because a bunny is an animal. I think that this is
It's a
the
very good
first
question.
order, and this would be the second then, yeah.
Yeah, I think the bunny would, so the second one, the bunny would
Yeah.
be called, yeah. Because it is a bunny, yeah, it is inherited, so it is.
It is an
bunny,
animal,
and,
yeah.
Yeah. Okay, I think we should continue.
Yeah.
Yeah, okay, one more.
It's possibly a tough question, but why don't you just, instead of template, can you just put auto and then just overload to one-time max? Is it possible? It's possible without template.
The same to just omit the template. It would probably be the same because it's the same. The compiler does nothing else but look what types did you use for the template and then overload those functions that compile them. And if you just don't consider it as if that exactly.
To sum it up, for such small examples, we could do other implementations, other stuff. We could use auto in this case, but with templates, we could do also larger stuff, and we could also have template classes, which we'll see in a minute. So templates is not only for one-line functions, but also for larger stuff. So then it's not the same as just replacing it with auto. Okay?
Yeah, but as you said before, we can also create template classes, which are then, of course, a bit bigger. Yeah, so let's continue with that, I think. Template classes means that we are not using just one function as a template. We can create a whole class of template. And now I think there is the time where you have one aha moment. At least in my opinion, I had it back then. A template class is written very similar. So you write template and then type name, which just means, again, that the following is our variable name for data types. And then you can create here a class. In this case, I create the class array of free, which holds an array of free elements of any data type I can specify. And I have two methods inside: the get array, which returns me this t pointer for whatever data type, and the get size. And this line looks a bit familiar because this is my array of free, and I define now the integer. So I want to have an array of free with integers. Any idea where you have seen that already before? Yeah? Yeah, so at vectors, for example, it's the same writing style. So we will see now, and a little bit later, vectors are basically just templates. So we can create here, when we create the object, we can say what data type it should be, and we create an array of free integers in this case, and we can use this then as it would be an integer array, because it actually is an integer array. So we get the pointer here with get array. So we really get the raw pointer. So this array pointer, and then we can iterate through that here and set the values. We usually at vectors, we said we should use the .add method. It's currently not implemented. That's why we're not using it, but you could do it. We could also implement a set method, for example, at a specific index. So this is a very, very short and compact version of what a vector looks like, for example. Yeah, and then we just print it, and as you can see, the output is 1, 2, 3.
And would it be possible to replace the integer not only with float, but also with bunny?
Yeah, of course. So you can use whatever you want here. You can also modify this t. So t is just standard. Usually you write t, but you can write any variable name here, whatever you want to do. You can also have 2 different names here if you want. So you can have a t and another one. Yeah. So maybe a t in the u or an x or whatever. And then you can use 2 different types on different locations in the class. Would also be possible. And what the compiler in the background again does, so it reads this template class, and at compile time, it sees, okay, somewhere in the code you're using this as an integer class, so with the template integer, so then I create this class with the integer array. And again, then it's as it would have ever been this integer array here. You can combine these classes for, interesting combinations. So you can have classes derived from template classes. You can create a template class derived from a normal class. You can have template methods. So there's a huge combination of templates and classes. I think we stay now with the basic ones. This is possible, but there's a lot to find out if you want to get deeper into this.
Yeah, and this is just a benefit for us when we program, because as we showed you after compilation, it's as if we would have written this code. So the compiler, translate the templates to such code.
I said before that it looks a bit familiar. It is like the vector, for example. Maybe we should have a look now what type of templates there are already existing currently.
Yeah. And therefore we come to the C++ standard template library STL. And this library, you've already used it. And this library is classified in at least those 3 components that are mentioned here, which are the containers, where, for example, the vector is in, and also a map you have already used in the practicals, or in the KU at least. Some algorithms, they can be used throughout different containers. So algorithms, basic standard algorithms implemented in this library, and also iterators to go through the elements within the container. So if we have a vector, we want to go through all the elements in the vector, and we can do this with iterators. And on the next few slides, we will have a look at the containers and also the iterators first. So what are iterators? As I said, an iterator is basically just a pointer, or is an object that points to the elements within the container. And I can access the elements through this through an iterator, or I can move the iterator through the elements in containers. How does it look like? We have a few short examples here. First, we have a vector of integers with the integers 1, 2, and 3. And we have a for loop where we start with such an iterator. We can declare an iterator by saying it is vector of integer which is an iterator of this type. Yeah, working with a vector of integers. So it is to read. And here it's just a variable name, arbitrary, but the standard is using IT for iterator. And I initialize it with v, which is our vector.begin, so with the first element of our vector, meaning that our iterator at the initialization of the for loop points to our first object in our vector, so to the first integer here. Then we have here the increment part of the for loop, where we can work with, in the same way as we work with integers, we can just use the ++ operator to increment the iterator, meaning that we move to the next object in the vector. So ++ is just incrementing the iterator, meaning that we move to the next or point to the next object in the vector. And we do it until we reach v.end. So v.end is the end of the vector, and if we reach the end of the vector, we want to break out of the loop or end the loop.
Yeah, this is always the time when I say I love C++ because it's so easy to write and but so easy to read.
But this is just for understanding, because there is a shorter and nicer solution. We will come to that. Within the for loop, we just want to print out the elements within the vector, and we can do it by dereferencing the iterator, so we get to the elements 1, 2, and 3. Yeah, there is a shorter version, a shorter way to do this, by replacing this declaration of the iterator with auto. So it's just auto IT, because with v.begin we get the pointer to the first element, and then with auto we automatically get an iterator. Yeah, the rest stays the same. And in this example, we do not only access it by reading the elements, but also by editing the elements. We can do it by dereferencing the iterator and then multiply it by 2, for example, and overwrite it. Yeah, and in the end, just to see that it worked, we have again a for each loop iterating again over the whole vector without a specific iterator, just a default for each loop to see whether it worked. And the output of this whole example is, in the first step, only the elements 1, 2, 3, and then after multiplying each element by 2, we get 2, 4, and 6 out of this third for loop. Yeah, just a first very easy example how to use iterators with a shorter version with auto. There was a question, yes? Yes, because we can work with the iterator similar as with an integer pointer, where we can increment it by moving to the next element or next 3. Yeah. Okay. Then let's come to the containers within the standard template library. The first container we just shortly discuss is the vector. You've already heard it and used it, and it's more or less a repetition. So it's a dynamic array, as you know, with fast random access, and the resizing of such an vector happens automatically. And the use case for such vectors is, for example, if you want to have dynamic resizing and frequent access by index, and there are some known functions as pushback, popback to add elements at the end, or removing elements at the end. Add is the method to access elements at a specific index, and size is the method to call if you want to get the size of the vector. For example, a vector with 3 elements, we can call popback, removing the last element. We can call pushback, adding the integer 4 to the end. And if we call v.add at index 2, we for sure get then the third element, which is in this case the number 4. So 3 is removed, 4 is added, and then we have 1, 2, 4, and the element at 2 is the integer 4. So the next container is probably new in this lecture and also in the KU.
Yeah, we had a linked list, but I don't think a double linked list in ESP, but it's pretty similar, or it's the same data structure implemented in C++, yeah.
So you can use it quite similar as the vector, but it has a different optimization. So it's a doubly linked list, and it's optimized for insertions and deletions within somewhere in the middle of the list. So if you have many insertions and deletions, so many manipulations of your data in the middle of the sequence, then list is the better choice than the vector.
So as a short recap, maybe everybody hopefully knows what a linked list is. Every member has a pointer to the next element. Double linked list is just every member has also a link back to the previous element.
Yeah, and this container offers us methods like push front to add elements at the front, push back to add elements at the back, pop front, pop back to remove them, and also insert and erase to insert or delete elements somewhere in the middle. And here we have a further short example where we use such a list, in this case with integers again, with the integers 3, 2, and 1 at the beginning. We push the integer 4 at the front. So after this line we have 4, 3, 2, 1. We remove 1, remove in this case, this is, takes not the index but the element itself. So it won't remove 3 in this case, it will remove 1 at the end, meaning that we get as output in this for loop 4, 3, and 2. So we added 4 at the beginning, at the front, and removed 1 at the end. So it's 4, 3, 2, then in the list. Next container is the stack. The stack is optimized for last in, first out operations. You can imagine a stack like a book stack where you put books one upon the other. And if you take books down, you start with the last one added, right? So it's last in, first out. If you have such operations, the stack is optimized for this. So yeah, you always have to think for your design, what operations are then frequently needed and frequently done, then you can choose which container fits best for your example or for your use case. Yeah.
For example, if you have a card game and you
could be the case.
Draw something from the card stack,
yeah,
a stack is a good idea.
Book stack, card stack, yeah. Okay, the functions here are, for example, push and pop. Push is to put elements on the stack, pop to take them down. Top is just always the reference to the top element, to the element on the top of the stack. And empty is just returns a boolean if it's empty or not, and the size, again, I think is clear. So one example how to use a stack is here by creating a stack, then pushing some integers 1, 2, and 3, and pop one integer down, and then, for example, call the top function, which will then return 2 because 3 was already removed from the stack. And here one example how to use empty. If it's not empty, then we print out not empty. So in this case, the output is 2 not empty because 2 is the top element here in this case. And for sure, it's also not empty. So we get 2 and not empty in this example.
Okay, next one. We have 4 more, I think. So halfway through already.
Yeah. Next one is the queue. It's basically or it's similar to the stack, but just the other way around. So it's first in, first out. It's a queue. So things you put in first, then are removed first. So push and pop is similar to the stack, but with FIFO operations. In this case, we have a queue. In this example, we push 1, 2, and 3. We pop one element, which is in this case not 3 as on the stack before. It's 1 because it's the first element that was added. And then we have some other methods here like front and back, which, yeah, as the name suggests, returns us the front and the back elements. So in this case, after removing element 1, we get 2 as front and 3 as back in this case. Yeah, use case, as we said, if you use frequent first in, first out operations, the queue. The next container is the deck. It's a double-ended queue, so similar as the previous one, but it's optimized for insertions and deletions at both ends. So if you want to add and delete elements at the front and the back, so it's double-ended. Yeah, so we have here push front, push back, push pop front, pop back, and we can use it like this. We have here a deck with 3 integers. We can say pop front, we can say push back, for example, and again we have front and back, returning us the front element and the back element, and we can also use the add method where we can access element at index 1. So this will return us 2, 5, 3 because we start with 1, 2, 3. We say pop front, removing the first element. We say push back, adding 5 at the end. And so the front element is 2, the back element is 5, and the element at 1 is 2, 3 is the element at 1. Okay. 2 more.
2 more, yeah.
The first is a set, which is a collection of unique elements. And in C++, they are automatically sorted. And yeah, the use case is if you want to have collections where you do not have duplicate elements in it. You have functions like insert, erase, find, or size, for example. And one example could be to have a set with the elements 4, 1, and 3. If I insert 2, 2 is inserted, but if I insert 3, it doesn't have an effect because 3 is already in there, and since there can't be duplicate elements in a set, nothing happens. So if I iterate through the whole set, then I get a sorted output of unique elements 1, 2, 3, 4.
Yeah. So until now, all of our containers were kind of specific versions of the vector.
Yes.
Yeah, so maybe with a different application and some different, in this case they're ordered, but they're kind of all vectors. The last one is completely different.
It's different, and I think you've seen it already in the KU a few weeks ago. It's a map where you do not have only one data type, but 2 data types, since a map consists of key-value pairs. And each, the key and also the value, could be of an arbitrary data type. So it's some kind of dictionary. You could imagine a map, dictionary like data structure. We have insert, erase, find, and add, for example, as the functions. And yeah, one example here could be that we create a map with integer data type for key and string as data type for the values, and I call it M, and then 2 different ways to insert stuff to this map. The first is with the square brackets by accessing the key. So I say my map at key 1, this has to match with the data type integer, is the string, very good. So I created one key value pair, which is 1, very good, and this is now in my map. And in the next line, I insert a second one with the insert method, with 2 as key and good as string, as value. And if I iterate now through this map, you have, I think, seen this in the KU. I not only have one variable here, but 2. I have one for the key, one for the value. And if I output the key and the value, then I get 1 for very good and 2 good.
I have a question to you because it just came up in my mind. Which container, not only in C++, but general, is most often used by you? So which one do you use usually?
So I think it's the vector.
Yeah? Okay, yeah, me too. Second one?
Second one, probably a set.
Okay, for me it would be the map. So
Third place for me, I think.
okay, yeah. So maps, unusual. I didn't expect that when I learned about it, but maps are very, very common, also in other programming languages. And it's a very, very nice way to combine and bind things together with a key-value pair. But interesting that you use more sets than maps.
Interesting, yeah. Okay. So
I think we can. Are there any questions to these containers? I know it's not that the most interesting topic now, but for completeness, we think we had to include it.
But I think you summarized it quite well. The first 6 we introduced were basically vectors with some specific optimizations, but then the set and the map, are a little bit different. So the set just takes unique items, and the map is, consists of key-value pairs.
Okay, if there are no questions, then I think let's move on to a completely different topic.
Yeah.
So templates looks good, is fine. Multiple inheritance is a special case, especially in C++.
Yeah, special case, especially in C++. And now we are at a topic that is related to object-oriented programming. And after that, we come to another one.
Yeah, last 2 topics, I
Composition,
think.
yes, last 2 topics. Multiple inheritance. The basic idea of this concept is that a class can inherit not only from one parent class, for example, animal and bunny, but can inherit from several. So the bunny doesn't only inherit from animal, but also another class. This is called multiple inheritance. This is the basic idea. Yeah, not all object-oriented programming languages support multiple inheritance. For example, Java doesn't, but C++ does. And now let's have a look how this could look like with an example. So we have a student class with a ID, which is more or less the matriculation number, then the getter for this matriculation number, and we have another class, faculty member, which is some person working at the university. So there is a department as member, which is a string, and also a getter for the string. And then we have here another class, which is inherited from student and faculty member, and in this case, this would be the university assistant, like you.
Yeah, I'm still a student, still one of you.
Okay, yeah. Now let's have a look how this looks like in the code. So we have the student class with, now it's correct, the matriculation number, and we have a constructor and the getter, and we have the faculty member with the department and the getter for the department. And then we have the university assistant, which inherits not only from student, but also from faculty member. Has a constructor calling then the base class constructor from student and also from faculty member. And if I create such a university assistant, I then pass the matriculation number and also the department. And then I can say, I can call the getter from the base class student to get the matriculation number, and I can also call the getter from the faculty member class, which is the get department method. So as an output, I get the matriculation number followed by the department.
That sounds and looks pretty straightforward and easy.
Yeah, but there are some problems that come with this principle, and yeah, as I said, it's not implemented in every language, and yeah, there's a reason why it is not implemented in every language, but it is in C++. As I said, in Java, for example, it's not implemented, so you can't use multiple inheritance in Java. In Java, it's only possible to inherit from only one class. Yeah, Java removed this concept maybe because of the two problems we now have a look at. The first one is the ambiguity problem, and the second one is the diamond problem. So two problems we have a look at. The first one, we have here a similar example, again, a student and a faculty member. Now we have different members for the classes. We have an ID as an integer, which could be the matriculation number with the getter, and we have then here for the faculty member also an ID, which could be some kind of member ID for the worker at some worker ID. Yeah, and also a getter for this ID, and then we have again the university assistant inheriting from both base classes. Yeah, again, student class with the ID and faculty member class with the ID as shown in the UML diagram before, and then we have the university assistant inheriting from the student and the faculty member again. And then in the main class, in the main function, we create a university assistant object passing again a matriculation number and an ID for the faculty. And then we call the getID, which we can do since when we look back to our UML diagram, we have a getID in both base classes, in the student and in the faculty member.
What do you think is called, or what happens?
Error?
Any other ideas? Okay, yeah.
Sorry. Sorry for revealing. Yeah, it's an error because the compiler doesn't know what to do. It's ambiguous. So getID exists in both base classes, so it's not clear which one should be called.
But in general, the structure would work. So
yeah.
Unless I didn't call it like this,
yeah,
I can do it. Is there a way to like having these IDs in student and faculty member and still use it?
Yeah, so we can leave the classes as we implemented them, but we have to change something here in the main function to specify which ID should, or which getter of which ID should be called, and we can do this with scoping. So we can say with assistant dot base class, in this case dot student, getID, or faculty member getID, to specify which getID method we want to call. And now it's clear for the compiler. In the first case, we want to call the student ID, and in the second case, we want to call the getter of the faculty member ID.
It's clear for the compiler, but it's not easier to read.
Yes, agree. So, but this would work, and then the output is, yeah, the student ID first and the faculty member ID second. Okay, so this is the first problem that comes with multiple inheritance. So it's the ambiguity problem. So if there are similar members, similar methods in the base classes, then it could be a problem if I do not specify from which base class I want to call my methods. And the next problem is the diamond problem. And yeah, the diamond problem says that an ambiguity arises when a class inherits from two classes, so multiple inheritance, that both base classes inherit from a common base class. And this leads then to potential conflicts. And this is the so-called diamond problem, because when we look at the UML diagram, we have some kind of diamond-like structure.
With a lot of fantasy.
Yeah.
But yeah.
Okay. So we have again the student and the faculty member class. We have the university assistant class inheriting from both of those classes. But the student and the faculty member inherit from person. So one common base class. What does this mean? Let's have a look at an example. So we have a person class, very short, just for demonstration purposes, with a constructor that just prints something out. Then we have the student class inheriting from person. We have the faculty member class inheriting from person. And we again have the university assistant class inheriting from student and faculty member. If we now create an university assistant object, since we have some outputs in the constructor, what do you think would be printed in this case?
Okay, so the first line, what is printed is what? Person constructor, okay. Second one?
So you think person, student, faculty member? Okay, so the next suggestion is an error. Further suggestions? Yes, please.
I think the first one is you need stick to the last one. Yes, first one, and then could be student and faculty, then person. From.
Okay, from bottom to top. Further suggestions?
Is it person, student, person, faculty member, and university?
Interesting. Person, student, person, faculty member, university assistant. Interesting, yeah? Yeah, let's reveal the output. It's person, student, person, faculty member, university assistant. So you were right. But why is that? So we see here two person objects that are created. Why is that the case? Yes, correct. So just again for the recording, for the university assistant, a student has to be created, and to create a student, a person has to be created. And to create a faculty member, a person has to be created, and then the university assistant can be created. So in this case, we create two person objects. And this is not what we want to have, because there is only one person, which is a student and faculty member, and finally a university assistant, but not two different persons. So we do not want to have two person objects. The next example shows why we do not want to have that. So I extended the base class person with the speak method that's just says hi. And if we call this speak method, what could the problem be here? Yes, please.
Just say it twice.
Twice. Okay. One suggestion is that it prints it twice. Further suggestions? Great, thank you. Yeah, an error again because, again, similar as with the first problem, the ambiguity problem, which speak method of the both created person objects should be called. So it's not clear, so it's an error again. Correct. Yes, please.
If you were to specify a scope and say student dot student dot speak, then it should probably work again because then it knows it should use the person object of the student with
Yeah.
the faculty member as well.
Correct. So one solution would be to use scoping, but as we have seen before, it's not what we want to have, and it's, I think, not the best way to deal with that.
Yeah, because we still have two persons. Yeah.
Yeah, we still have two-person objects. So the first, or yeah, the solution for this problem would be to add virtual. As we've already know this keyword, we can also use it in this case. So we say virtual public person. So we inherit from two virtual classes, so to say. And then we have the same effect as you already know for setting methods to virtual. And then in this case, if we check the output, we have just one person object that is created. Yeah, so in this case, virtual is the keyword that we want to use to solve this diamond problem in this case. Are there questions so far? Yes, please.
If we create a class that inherits from two classes, when we consider polymorphism, can that derived class be stored as a pointer of both of those classes? So can a university assistant be stored in a pointer of student, as a pointer of student and as a pointer of faculty member?
Yes,
Yeah.
Should work, yeah?
Yep. Because it's again, it's an is-a relationship. Yeah. So it is a student and it is a faculty member.
If you were to access the pointer, you would then, if it's a pointer of student and you save the university assistant with the pointer of student, you would then only be able to access attributes or functions that are specified in student. So if you have, for example, the student class has get matricle number and the faculty member has get faculty ID and the university assistant has get university assistant ID, then you would only get the function and properties of students, and you could only call get matricle number because the compiler and the program does not know that it's actually a university assistant in there and also a faculty member. It just thinks this is a student, and it only looks for those methods that you
Even if I scope it?
Even if you scope it, because you cannot scope it from a student to a faculty member or a university. You cannot scope downwards, you can only scope upwards. And you can also not scope horizontally because that's exist. Okay.
Okay, to sum it up, similar as with a bunny and an animal, if you use a bunny object as with an animal pointer, you can just access animal methods and attributes, but not the bunny specific ones. And same is holds for this problem. If you just interpret it as a student pointer, you can just access the student specific methods like matriculation number, but not the department, for example. Okay, and for the second example with the speak method, when we use virtual here, when inheriting from person, we can call the speak method, and then for sure, since we do just have one person object, we can call the speak method, and it's not ambiguous, so then it prints hi.
Yeah,
okay,
so that works. One more thing to multiple inheritance. We already saw it, I think, at some point, because maybe it raises the question, why should I use it or when is it used?
Yep.
It is already used and implemented in C++.
Yes, and you all have used it already?
Yeah, in a very complicated way.
Okay,
let's say.
But let's have a short look at that. So this is just an overview of in your UML diagram of
different libraries,
yes, different libraries in C++. And there you can see, for example, the input stream and the output stream classes, and the basic IO or the IO stream class inherits from I and O stream. So this is one example where we have this multiple inheritance, and since both of those classes inherit from iOS, we have also this diamond example in this case. So this shows us that it is used in practice. For example, in the C++ standard library, it is implemented, as we can see here.
Yeah. Then let's move on to our last topic of the whole semester and
Not
whole
only
lecture.
for today, but for the whole
Yeah.
lecture. Yeah.
And it is more like an idea or a principle of coding. So it's composition, and it is an alternative way to use inheritance. Let's call it like this. So when we remember, inheritance is a relationship. Yeah, a dog is an animal, and so on. The composition is just has a relationship, and has a means it's a member of it. So it does not inherit from a class; it just uses members to use relationships and build something. So the principle in general is composition should or could be used over inheritance. It's a bit of a design idea in general, yeah, and there is no right and wrong. But in general, I think composition is more powerful than inheritance.
Yeah, and I think we'll see an example where it totally makes sense to use composition over inheritance, because it could get complicated.
Yeah. And these components, so the members you have are a bit more flexible to use and also allow you to modify them during runtime. But let's see a short example with inheritance. So we have a pizza, and this pizza has a virtual getPrice method, which returns 10, and then we create our pepperoni pizza, which is derived from the pizza class, overrides the getPrice, and say, okay, we take the 10 euros from here plus 2 because there's a different topping, the pepperoni on it. And then we want a pepperoni garlic pizza, which inherits from the pepperoni pizza. And again, we want to add 1 euro. So this is nice. This also works. We can create a pizza, we can create a pepperoni pizza and a pepperoni garlic pizza. We can get the prices out of it. Yeah, so far so good.
Yeah. So this is now with inheritance, we can say a pepperoni garlic pizza is a pepperoni pizza, is a pizza.
Yeah, it still is, yeah. But it's not that easy to add further toppings to that, yeah. So when I want to have only a garlic pizza without pepperoni, I need to write a new class derived from pizza, and so on. So it's a lot of work to do for just one modification, maybe.
Yeah, and I think for most pizza menus, 3 pizzas are not enough, right?
No.
So
yeah. So this is again the UML diagram. As we said, pepperoni pizza is derived, and pepperoni garlic pizza is derived. The composition is different to write. It has a different concept, but you can use it for the same applications. So we have a topping class now. So it's a little bit different. We have a topping class which has a price. Topping is the garlic and the pepperoni. Constructor and the getPrice as we know it. And then now it's getting different. Yeah, we have our pizza class, but instead of inherit the pizza class, we just create a vector of toppings. Call these toppings. And then we have some different functions again. For example, here the constructor. At the constructor, we create these toppings and add it already. The getPrice, where we iterate over this vector and get just the price of each topping. So we have a start price of the pizza itself, and then we can create different topics on it. And we again first create our pepperoni topping with a price, a garlic topping with a price. We create just a pizza element, yeah, and then, with in this case, with no topping, yeah, not
Margarita?
that. Margarita has still something on it. This is maybe just the pizza bread, yeah.
Okay.
Then here we can just specify, okay, this should have pepperoni on, this should have pepperoni and garlic on, and again, we can get the same prices. But as you might see now, it's very easy to add new toppings to it. So instead of inherit that and always write new classes for specific types, you can use this vector here to specify different variations of a pizza and what's added on this pizza.
Yeah, so for composition, we do not need any new keywords. So it's just a concept that in many cases makes sense to use it over inheritance, as we showed in this pizza example.
Yeah, and also the UML diagram gets a bit easier because you have the pizza and you have members, which are again other classes, and these members, in this case the topping, can now specify the type of the pizza. And that's basically what composition is. So whenever the inheritance maybe get too complicated, and as I said, you always have to define new classes to create a special type of the base class, composition might be the easier choice to implement in general, implement your idea.
Mm-hmm. And one further remark regarding the UML. So we do not have an arrow for inheriting, but we have here this diamond for composition. So we read it that the pizza has a topping.
Yeah, it's not the diamond problem here.
No, it's not the diamond problem. Okay.
Yeah. Any questions to composition? I think we skipped that. No.
Okay.
Then let's move on to our last slide of the year.
Summary for today, for the whole lecture, for the whole semester. In the lecture, yeah, we had a look at template functions. We also have seen that we can implement template classes. We have seen such classes. We haven't seen examples how to use it with different data types then, and how the compiler, or what the compiler does for us. Yeah, compiles or translates it to specific classes or specific functions. Yeah, we had a look at the standard template library with the iterators and containers, and also discussed or just gave an overview that there were all different algorithms implemented within this library. Then we had a look at the concept of multiple inheritance with the ambiguity problem and also the diamond problem. And last but not least, we had a look at the concept of composition, showing you the advantage in some cases over the inheritance, which is the is a relationship, and the composition is the has a relationship.
Yeah, so thanks for being here. One last remark. Next week, practicals is a must-have because they prepared a lot of, so please come. It will be fun. Yeah.
Thank you very much, and all the best for the exams and the practicals.
Yeah, thank you.
Thank you.